is to understand the concept of gas. Okay, so this is a good example to bring it to you to reality. And another law is Charles' law. So Jacques Charles discovered that the volume of gas is directly proportional to the temperature. That means, so the volume here is directly proportional to temperature. That means if I increase the temperature, I will increase the volume. Okay, so this is why if I have my car here and in Florida, which is very high temperature, and I would have a portal that would transport me to Norway, very cold place, and what happened with my tire will not be so good as over here, because the temperature here is so high that the gas start getting, like, the speed of the movement of the gas will be really fast because the temperature is high, so the volume increase. If I decrease the temperature, what happened? Will decrease the volume. Okay, so when you write the Charles law, you're gonna find that volume divided by T1 is equal volume divided by T2. This is constant, so that means doesn't matter how much I change the volume, the temperature will change. Okay, so if I increase the temperature, I will increase the volume in the same proportion. So this is why this result will be constant. Okay, if I decrease the temperature, I will decrease the volume. So this is why it's a constant value over here. So as the balloon, when you cool from a room temperature with liquid nitrogen, the volume decreases. I think that you have seen this experiment before. So if you grab the same balloon here and then put in a hot water, what happened? The gas that is over here in the balloon, so they are more close together because they are so, like, they start stopping, reducing the velocity because it's so cold. So the velocity, the speed, the movement will increase. So they start hitting the wall of the balloon so fast, so that balloon will get back in this form over here. Okay, so temperature increase, the volume will increase. Let's apply Charles' law. So 132 liters helium balloon is heated from 20 degrees Celsius to 40 degrees Celsius. So let's talk a very important thing here about units. If it's pressure or it's volume, since you keep it you're consistent with the units, it's okay to keep millimeters mercury or Pascal or liter or milliliter. Just pay attention what the problem asking you for. But temperature, you cannot live in Celsius. Remember, in gas, we're gonna use Kelvin. Okay, so to convert to Kelvin, so we have a Celsius, so you're gonna add 273, and then we're gonna have Kelvin. So the first thing that you need to do is to convert the temperature Celsius to Kelvin or Fahrenheit to Kelvin. Okay, so we have 20 degrees Celsius, so that's the first thing that I'm gonna do, and I will have the temperature in Kelvin. So that is the initial temperature, and this is the final temperature. So what happened with the temperature? Increase. What's going to happen with the volume? If I increase the temperature, the volume will increase because the molecule is more agitated. The movement is faster, so they will hit the walls really more times than before. So we'll increase the volume. So we have the formula. We know that V1 divided by T1 is equal V2 divided by T2. Oh, sorry. So if I multiply by T2 on both sides, so we're going to cut over here, and they're going to have this formula over here. Okay? Little bit of algebra again. So now I have my data. So I have the volume and I have the temperature already in Kelvin. So my volume is 141 liters. That's good. The volume increases as we expected, right? So let's do again together. So a balloon is filled to a volume of 2.20 liters at a temperature of 22 degrees Celsius. The balloon is then heated to a temperature of 71 degrees Celsius. Find the new volume of the balloon. So the first thing that you need to do is listing all the data you have. So you see that we have volume and we have the temperature, so we know that we're talking about the Charlie's law. So the moment that the temperature increases, I know my final volume will increase. So organizing the data is this. So I have volume 1, and I have T1, and I have T2 over here. So now what I have is the formula. I know the formula is V1 divided by T1 equal V2 divided by T2. So what I want is V2, so I got this. So now it's just plugging your data that you have already. So now we're gonna have V2. What happened if the volume increases? That's right. So this is what we were expecting before, right? So it's important to practice. It's important to read well your problems because it's easy. But if you're not consistent with your units, you're gonna make mistakes. I could mix over here Celsius with Kelvin, and you know that the temperature you need to convert all to Kelvin. Here it would be easy, but when you have like pressure and volume, I could mix pressure ATM and the other pressure with millimeters mercury. So pay attention in the units, okay? Let's do one more. I have here a 2.50 liter sample of nitric oxide gas at 100 degrees Celsius, which is cooled to 20 degrees Celsius. If the pressure remains constant, remember all the time they say pressures remain constant, and they don't say anything about the number of moles. We know that N is constant as well. Okay, so sometimes it only tells you, okay, the pressure is constant. What I'm varying here is the temperature. So I have volume and temperature, so I know that we're talking about the Charlie's law. Okay, so what are you gonna do now? So I know the volume 1 is 2.50 liters. I know the temperature 1 will be 100 plus 273 will be 373 kelvins, right? And I know that temperature 2 is 20 degrees plus 273 will be 293 kelvins. And what I want is volume 2. So the temperature decrease. If the temperature decrease, what happened with the volume? Will decrease as well, right? Because when the temperature increase, the volume will increase. If the temperature decrease, the volume will decrease. Okay, so they are directly proportional. Okay, so let's do math. We know that V1𝑇1 is equal V2𝑇2. What I want is V2, so V2 will be V1 times T2 divided by T1. You're gonna just plug in your data. So I have 2.50 liters. I have T2, which is 293 kelvins, and I'm gonna divide by 373 kelvins. So I'm gonna do this math by myself over here, but you can do your math over there. So I have 2.50 times 293, right? Equal, divide, okay, by 373. And we're gonna have 1.96 liters. Okay, So what happened to the volume? Decrease as we expected. So if you change this to temperature over here because you made a mistake in algebra, so you know that you did wrong, because you know that it's supposed to decrease